All right, so in this lab, we're going to talk about access control lists, ACLs. So I have a lab document, like always, and let's go ahead and get started. Talk a little bit about what we're going to be doing here. So first of all, if we look at where we are in our lab, we've configured single area OSPF in a previous lab, and we've also done NAT. We are going to be configuring access control lists on actually two different types of routers. One's going to be our edge router, which is kind of a natural control point for ACLs that regulate traffic entering and leaving the enterprise. This is where we enforce security policies such as filtering inbound connections, preventing unauthorized traffic from reaching internal hosts, and ensuring only valid traffic like non-RFC 1918 addresses leave the network. Another kind of natural point is our distribution routers. This is where we'll apply ACLs that allow us to define which networks and hosts are permitted to communicate with each other and which ones will be denied. It's also kind of like mini firewalls in that we'll be permitting denying traffic to help enforce internal security zones, preventing unnecessary and or unauthorized communication from within the network. Now, in my document, and I'll be pointing to this several times in this presentation, I talk about the difference between standard and extended ACLs, numbered or named. We'll be using mostly extended named ACLs, because everything you can do in any type of ACL, you can do in an extended named ACL. And it's kind of the best practice. But there will be one point where we'll use a standard named ACL. But anyway, let's go ahead and get started here. First thing I want to mention is that we are going to be applying a list of access control entries, statements that create the access control list. And just a couple of things I'll be reminding us of throughout this is that the ACL is checked sequentially. So once a match is found, and I can kind of show you an example of what I'm talking about. We'll be doing this in a moment here. So here's one of the ACLs we'll be doing, a list of statements. So these statements are checked sequentially. And once a match is found, whether permitted or denied, no further ACEs, access control entries, are checked. Also, at the end of every ACL is an implicit deny any. So we'll be talking about that. That means if we don't specifically permit it or do a permit everything, then it's going to get denied. The other point that I want to mention is that any traffic that originates from the router. Let's say you're on a router, you're CLI, and you're doing a ping, or it's sending the router happens to be sending a routing message like a OSPF hello or something. Those packets are not filtered by an ACL, and that'll come into play here in a moment. The other thing I want to mention is kind of the order of operations. And with every ACL, I'm going to remind us of what that order of operations is and where ours is being applied. So we'll see there's inbound ACLs, then routing happens, then it looks at NAT, and then it applies any outbound ACLs. So that's kind of the general order. And excuse me. And again, I talk about this in my lab document. And if you want further information on this, well, you know what? There's a Cisco web page that goes into great detail. Okay, so let me close that. Let me move this out of the way. And I think now is a good time to get started. But before we start the actual ACLs, there's a couple of things I need to do. So on Edge, and I'm going to log into Edge here. Just remind everybody, Cisco, and then enable class. Okay. Okay, as you can see in my lab document here, come up pre-ACL configurations. We are going to remove the discard route. We had configured a discard route way back when we were doing OSPF, before we were doing that we made sure that nothing from our 10 network was destination IP address was going to ISP, because it would just do a hairpin and bounce it back to us. We're going to see that with NAT that we did last time, that everything is being translated to a 209 1010 address and going to ISP, but we're going to handle that discard route with an ACL. So we're going to remove that momentarily. The other thing that I'm going to remove is when we did NAT, we did a static NAT. And that was that allowing anybody from the outside to access our engineering server using this IP address. Well, that's not really best security practices. And we'd actually probably move something like that into our DMZ and enforce some security policies on Edge. So I'm just going to go ahead and remove that. So let me go ahead and move this out of the way. Let's go to Edge. And I have, and I think I've showed you this previously, I've got all my configurations done in a text document. So I'm just going to copy both of these. Make it really easy. Make sure I don't make any mistakes here. They be in the global configuration mode, paste. And so this is where I've done both of these. Okay. Oh, I need to make a slight change here. Hold on. Okay, so you may see something's missing. I had my completed packet tracer topology up after I did all the ACLs. This is my startup, so that's why I tried to erase or delete the discard route, it didn't find it because I had already deleted it. But that gives me a better opportunity here. What I want to do, I'm going to use do show command, do show IP route static. Put that do in front, allows me to do this in global configuration mode. And here is our discard static route. So I'm going to go ahead and delete that. So let me go ahead and copy that in again. So I'm doing this again, copying it. There we go. So this time it says, yes, I deleted it. And I've also deleted the static discard route, or the static NAT. Okay. It's early in the morning for me right now. All right. So the first thing we're going to do here, let me go to our document. The first ACL that we're going to apply is we're going to apply some ACLs on Edge. Now we're going to applying both outbound and inbound from the ISP. We'll do that first, and then later inbound and outbound to our network. Okay, so what kind of ACLs do we want to apply this to between us and our ISP? Well, one of the things we want to make sure is that we are not sending the ISP any RFC 1918 private IP addresses or any of the special use case addresses and things like that. And I've got some information here, and I'm going to show you the ACL. So we're going to be applying our first ACL outbound on Edge, gig 00. And let me show you the ACL we are going to be applying. So the name of this ACL, it's going to be an extended ACL, and here's the name. I gave it a name that's clear to me. Use these remarks so I know what parts of my ACLs are doing what. And I like to just mention the order of operations. This is an outbound ACL. So any destination IP address has already been added. And basically, it's already said it's going to be sent out the interface towards the ISP, and it's also already been added to our 209.10.10 address. What we're doing here is making sure we're denying any source and destination addresses that are part of the RFC 19 private IPv4 address space. That doesn't happen by magic. Okay, as we learn in our introductory networking classes that the internet does not route private IPv4 addresses, that doesn't happen by magic. We have to make sure that we as an enterprise are not sending that traffic to the ISP. And the ISP is going to make sure it's not receiving it using ACLs. And we're going to do the same thing, make sure we're not getting that kind of traffic from the ISP. Okay, and then here are some special use case addresses that we're going to be checking. These are like loopback addresses and some others as well, both source and destination. I have some explanations coming up in a moment. We're also going to deny any of our, so this is source IP. So this is saying anything, doesn't matter the source IP address, and then this is the destination IP address. So let me just mention this a little bit. So in our configuration here, this is an extended ACL that we are using. So the first address is always a source IP address, and the next address is the destination. Here I'm denying any IP address packets with this source going to any destination. I'm also doing the same coming back. So I'm saying I'm denying any IP packets coming from any source going to this destination. Okay, so this is coming from this source, going to any destination. This is coming from any source, going to this specific, with this specific destination IP address. This is saying a specific host address. These are special use cases. Now let me come back down here. Here we're denying any source IP address going out to, this is a band network. That's what I have here, band server, band network. So we're not allowing, that's just an example how we can deny packets going to a specific network. This is where we do our discard route. We are denying any IP packets, any source IP address going to this with this part of this destination IP address. This is making sure that we are not sending packets with the destination IP address 209.10.10 anything. Why is that? That's our public IP address. The ISP is just going to bounce those back to us. And again, the way we read these with the wildcard mask is just as a reminder, the 0 means check, 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 and then this means ignore. So what this means is we're checking the first 24 bits, first 3 octets must match. If those match, and we don't care about the 4th octet, but if the destination IP address matches 209.10.10, those first 24 bits, we are going to deny it. Now, there's an implicit deny any at the end, meaning any source, any destination. So we want to make sure we do permit everything else. So this permit here says, after looking at all of these that we're going to be denying, we are going to permit anything else from any source to any destination address. We are going to be applying this access control list outbound on gigabit 00. All right, so in my configuration here, I have all those commands. Now, this is actually the beginning of the ACL, but notice I first removed the ACL. Why do I do that? In case I want to make any changes, I can just make the changes here. When I run this, it's first going to remove the existing ACL and then create a new one with my statements. So let's go ahead and do this. And at the same time, I am going to apply it outbound. Copy all that. This is going to be on edge. Let's paste it in the right place here. Make sure that there's no mistakes. And that looks really good. Okay. Now, I want to mention that in my document, I mention all those special use cases, where they come from, what they are. All right. Now, we're also going to apply similar policies coming in from the ISP. Okay, so let's take a look at, this is going to be a inbound access control list coming from the ISP inbound to edge. And so it is going to be applied before any routing. So as soon as that packet enters that interface, this ACL is going to be applied. Before routing, before NAT, and of course, before any outbound ACLs. This is where we want to make sure nobody's attempting to be us. So anything with a source IP address 209.10.10.0, that's going to be the first 24 bits matching. That source IP address is going to be denied. Why is that? Because that's not you. That's us. So that source IP address should not exist anywhere out here. That's our public IP address. Okay. Similar to what we did before with RFC 1918 and special use case, we're denying source and destination addresses for those. Similar to our band network, we are denying anything coming from that band network. That's the source IP address. Destination doesn't matter, we're denying it, and we're permitting everything else. Okay. So let's go ahead and do the same thing. I'll move this out of the way once again. Find my there we go. You were there someplace. Okay, same thing. I created a text document. First of all, I'm deleting that ACL, then I'm going to recreate it. Copy all that. All right, let's go ahead back to Edge. Make sure I'm at the right prompt here. Yes, I am. Going to paste that in. Okay, kind of looks the same, doesn't it? Make sure it's the inbound, right? That's what we had. IP access group inbound on gig 00 in. Let's go back to Edge. That's what that was. All right. So make sure we didn't have any errors. I think everything looks good. All right. So one of the things we want to make sure is that we didn't break anything, right? So things that we want to continue doing, let's make sure that we can do. For example, let's go to PC0 here. And what I'm going to make sure is that PC0 can reach, first of all, our internal, or I shouldn't say, our public web server that for our enterprise. And we also want to make sure it can reach the permitted web server, this server here. What else do we want to make sure? Make sure NAT is working, and let's make sure that we cannot reach the band network. So let's do this. Let me go to desktop, web browser. Let's do 209.10.10.100. I think I got this right. Yes. There we go. Public company website. I called it, lack of better something to call it. Let's go to the permitted server, 1.1.10. Make sure that's okay. Yep, permitted server. Okay, that looks good. Let's check, make sure. What is this? Command prompt. And let's make sure that we can't get to 99. Let's take that address. There it goes. .99.99.10, that DN server. Destination hosts unreachable. That's what we want to see. Okay. Let's also make sure that our permitted server there, that's because that's really the only client we have out there, right? Can get to our public web server. So people from the outside can get to our public web server. Let's take a look at that. There we go. All right, that's looking good. All right, let me jump back to Edge here. I did show access list question mark, and I can give an ACL number, ACL name, but since I have just two ACLs, we can look at this fairly easily. I talked more about this in my presentation, how Cisco iOS adds sequence numbers to the ACLs, and you may see something in slightly different order. So it may rearrange some of your access control entries to process them more efficiently. The sequence numbers are used so you can, if you wanted to insert an entry within lists, you can do that using a sequence number. Personally, I just prefer to do my as you saw my complete list, remove it, add it again, just copy and paste. But what I do want to mention is, let's take a look. Here is this is NAT. Oh, so NAT is happening. We'll take a look at that here in a moment. But this is our outbound ACL. And let's see if there are any matches. Yes, look at this. Remember when we tried to reach the 99 network? It's banned. There's 4 matches. Said, nope, not letting you in. Okay, our inbound, everything was permitted coming inbound. Okay, so it's showing any matches that might have happened. And just to remind us, we are doing NAT, show IP NAT translations. Okay, so that's why we are seeing, when we're using an ACL for NAT. Okay. All right, so let's go ahead and continue with this. Let me bring over the lab document once again. Now what we're going to do is take a look at what we want to permit to come into Edge from our enterprise. That means also going to the DMZ or going out to the internet. So let's take a look at that first, and then we'll take a look at what's going out to the enterprise. What we want to do is we want to permit just web traffic, port 80 and 443. Packet tracer only supports port 80. Permit any traffic leaving the enterprise, port 80, port 443. That's good. Any pings, ICMP echo requests going out, we're going to permit that. We're also going to permit packets to Edge's specific IP address. We're going to use that later for when we want to SSH or Telnet, only in a lab environment, Telnet into Edge. We'll see that later. Now I've added some other ones, some trace route. Well, we're going to do trace route as well, but I mentioned that up here. We're going to have both pings and trace routes leaving the network that originate from the network. Now, this trace route here is something that is not part of packet tracer, but some operating systems like Linux, Mac OS, and even Cisco iOS uses port numbers, UDP, and high port numbers to or unreachable port numbers to do trace routes. I won't get into that here, but I've just showed you how we can add that ACL here. Last but not least, this is important. We are running OSPF. Okay, so let's take a let's take a look at this. It's the best way to do this. Okay, so here's our ACL. This is going to be inbound. I'm calling it, but it's coming in from the enterprise. Okay, so it's going to be checked before any routing or NAT. So any of our, what's important here is it happens before NAT. So our source IP addresses are still going to be 10 addresses because they have not been NATed yet. Okay, so we are going to permit any of our internal devices, anything beginning with a 10, this to reach our DMZ. That's this network here. We're going to permit any of our devices, our devices in the 10 network. Okay, where it has a TCP where the destination port. So let's look at this real quick. Permit TCP, this is our source IP address, any destination IP address. So anything source IP10 network going anywhere, and then equal port 80, that's www. Because this port number, port 80, www, or port 443 follows the destination address, it's the destination addresses, this means the destination port. So we're going to permit those. We're also going to permit any ICMP messages coming from in our network, going anywhere that are echo requests. Okay. This is where we're going to allow anything from in our network, any IP packet going specifically to edge. That's the IP address on edge. We're going to use that later for when we VTY, when we telnet or SSH into edge. This is for trace routes from other OSs that don't use ICMP echo request, but uses UDP and port numbers. Don't worry about that, but it shows you how we would do it. This is important. So if you remember, one of the things I mentioned is that that we are running OSPF, so we have to allow OSPF messages coming from core, or they'll be denied. Okay, so this is permitting any any OSPF messages coming from any source to any destination. So we're allowing all those OSPF hellos, LSAs, anything that's coming in from core. Okay, talk about why we won't need to do that going outbound. Okay, and everything else is implicit deny. Deny any. So we're denying everything else. Okay, and we're going to apply this, the name of this ACL, we have right here. Can we see it? Can we see it? Yeah, there it is. Okay, we're going to apply it inbound on gig 01. We're inbound on this interface. All right, so let me move this out of the way. Sorry, got a little frog in my throat. Okay. So let's go ahead and apply that again. Here's this is telling me I'm on its edge and it's coming in from our internal network. That's just a little note for myself. Big T. Let's paste that. Make sure there are no mistakes. Okay. All right, let's do another one here. We'll do some testing. This is where I talk a little bit about the OSPF. Now let's take a look at what's going outbound into our internal network. We only want to allow TCP traffic that was initiated by the client. Okay, so that means that any TCP traffic that we're allowing into our network must have been initiated by a client from the inside, from within our network. I am sorry about this frog in my throat. Just can't seem to get rid of it. Drinking water and everything. You're even hearing me drinking water now, not even pausing anymore. Okay, sorry, just you'll need to bear with me here. All right, so that just means any TCP traffic had to be initiated from inside. That keeps anybody from trying to initiate communications from outside, trying to get inside our network. And when I say inside, our enterprise. Okay, so let's take a look at what we do here. So we are going to permit, first of all, this is an outbound ACL. So it's after any inbound ACLs, routing has occurred. So that means that the routing means, yes, it is routing it out this interface. NAT has occurred. So that means any destination IP addresses are now going to be a 209 address. Okay. I'm sorry. Said that completely wrong. It's been natted. So anything destination IP addresses, I meant to say that were 209 addresses have been natted to a 10 address, the private address. Okay, I think I've got that together now. Okay, again, 209 is coming in, it's our public, it gets natted to the 10. So we should see destination IP addresses as a 10 network. Okay, what else we allow? We're going to be allowing, echo, ICMP echo replies, not ICMP echo requests. So they only pings that were initiated from inside and trace routes. Everything else will be denied. Okay, so what's this doing here? This is permitting any traffic from our DMZ to come in. Okay, so that allows our devices to reach the our public web server and come back in. This is key here. This is saying that the source is fine coming in that gotten added to a 10 address, but the TCP's connection must have been established. That means it must have been initiated from the inside. Okay, that's an old TCP three-way handshake. We are permitting ICMP pings from any source coming in. That's our destination IP address after it was natted. Echo replies only. And same thing with time exceeded messages for trace routes. Don't worry about this. This has to do with UDP and QUIC if you're interested in that. And this is also for any trace routes that uses those UDP and port numbers. Everything else is denied. And we are applying that access list right here, outbound on gig 01. Outbound. So let's go ahead and do that. Move that out of the way. Again, you can see my little edge. This means going out to the internal. Here's the statements. Paste. Make sure no mistakes. There we go. All right. I think we can do a little testing again, right? Make sure, again, we didn't break anything. So let's go back here to PC 0. Okay. Still should be destination hosts unreachable or request timeout or some just should not permit it, right? Let's go back here, make sure that we can reach our, and we are permitting outbound port 80, port 443. So this should still be okay. Yes. And we should be allowed to access our own web server. Oh, what did I do here? Oh, type that in. On. There we go. That's better. Okay, and let's just make sure that this permitted server still can get in here. All right, that looks good. Okay, so next, what we're going to do is we're going to do some internal security policies. So this is where on distribution DC router, layer 3 switch, what we want to do is we only want to permit engineering host devices in the 1020 1.0 network are permitted to access our engineering file server. That's one thing we want to do. And we're going to permit ports 8443 and FTP. Okay. Traffic from all other 10 networks, okay, are permitted to our DHCP server and our internal web server. Okay, and again, we'll need to make sure that we permit OSPF messages from coming in. So let's take a look at what this looks like. Okay, again, this is an inbound ACL, so it's going to be applied before any routing or anything. So that as it comes, we're going to be applying it inbound from core 1. Okay, so the first thing we're going to do is permit anything from any pings from 1021.0 network going specifically to our engineering file server that's permitting anything in this network, our engineering team, they can ping ICMP echo request, send pings to that file server, to that same host. So that same, from that same network, I should say, from that same network to that same host, okay, we are going to permit port 80 and TCP port 443. We're also going to permit, again, from that same network to that same host, ports 21, 20, and 10, anything higher than 1023. This is for FTP. And by the way, I talk more about FTP and that down here if you're interested. Okay. How about everybody else? Well, we're denying everybody else to that host. So if they are not specifically from this network, anything else, they are being denied. Now, it's important that we have this after these statements here. Order matters. If I had this denied before any of these permits, then it would never, then this also matches this. Everybody would be denied, including people or devices from our 1021.0/24 network. So we want to make sure that we permit them and then deny the larger network. Okay, then what we're going to do is permit any IP packets from any 10 network going to anywhere else in the 10.2.1.0 network. That's important that that comes after this deny. If this came before it, okay, then that would permit actually everybody to get anywhere, okay? So this is, well, if we put this at the top, that would permit everybody to get everywhere, right? Or even before this denied, permit everybody to get everywhere. So we want to make sure we deny everybody to this host, and then now we're going to permit everybody to everywhere else. Okay. So in other words, let me just say this real quick. We are permitting specifically first this subnet to get to this host. Then we're denying everybody else in the greater network to get to this host. And then we're permitting everybody in the greater network to get anywhere else. Again, once a ACE entry is matched, it doesn't check any further entries. Last but not least, we're permitting OSPF messages, packets from to come in from core into our distribution DC. Okay, and we're going to be applying that inbound here. So let's go ahead and do that. There we go. And it's right here. Cisco, enable class, config T, and paste. And make sure everything, no errors. That looks good. All right, now let's do a little testing. Okay, so let's go to PC0 here. And let's make sure that PC0 so if you remember PC0, you may not remember, it's not part of the network we're allowing access to this file server. So if I do a ping 10.2.1.12, okay, it should fail. Okay, good. That means also I can't FTP into it, right? Trying to connect, says, no, I'm not going to let you do that. Come on. There we go. Yep. Now it should allow PC0 to get to these two devices. So let's make sure that we can, it is allowed to get to 10.2.1.10. I have a little ARP request. There we go. And let's do 11. That should be allowed as well. And that looks good. But let's now, so that means we just tested that devices not in this network cannot get to the engineering file server, but can get to these. That's what we want. Okay, let's test one of the devices in the permitted network. Okay, so let's do this. So remember, this is one of the devices in the permitted network. Okay, so can it ping 10.2.1.12? There we go. Yes, it can. Let's make sure it can FTP to 10.2.1.12. There we go. Cisco. Great. Okay. And by the way, let's do something real quick here. A little directory. So on the PC, I have a little file. There's called sample file. Let's do this. And I show you more in another video and even in this document about FTP, but let's do it. Let's log in again. Oh, there we go. Cisco, do a directory. I'm on the server. There's the files that are on the server. I'm going to put that file. I'm going to copy that file sample from my computer, from this PC, sample file.txt. Okay. So it says it copied it. Let me do a directory. Look, it's there. Isn't that cool? Little FTP server. Okay. All right. So FTP is working. I think we're pretty good to go here. And let's just validate that we can ping the other ones as well. We didn't do anything to break that. Please don't ask me. So, didn't ask you anything. All right. Okay. We're almost there. We're hanging in there. Okay. Things are looking good. We can get to the 10, the 11. Okay. Let's do another one. What if on, let's see, where are we here? Distribution 3. Okay, we're almost done. Let's go just a couple more. It's a short one here. On distribution 3, what we want to do is, this is maybe like a guest network, or we got a classroom or some, it's for guests or whatever. We don't want them to have any internal access to any of our 10 network, except this server here, 10.2.1.10, our DNS DHCP server, but no access to any other 10 internal devices on our 10 network. But let them have access to the internet. Okay, so we're going to apply an access control list on distribution 2 right here. Okay, that we see that we're going to do is permit them to get to this host. So any IP address getting specifically to that host, but denying them from getting to, after that, any other 10 network host, but allowing them to get anywhere else, basically outside our network. I'm going to apply that inbound on this interface right here. Okay. All right, so let's go ahead and do that. Short little ACL. Cisco enable class. Okay, let's do I think we're good with that. All right, let's do a little verification now. Okay, so I'm going to let's get on this PC here. So I applied that inbound on this interface right there. Okay, so let's make sure that this device here cannot reach other devices like PC 0. So again, so this is the subnet we're on. This is being applied to this interface right here, gig 101. So I should not be able to ping 1.100. Yep. Say, nope, you can't get there. Okay, but I should be able to reach. We did say, we are allowing you to reach this server here. Come on, ARP. There we go. And we are allowing you to reach the internet. And we can see our access list in action. Once again, let me show this again. Show access lists. Okay, we can see that we had some matches, okay, that allowed access to this server here. We had some matches when we tried to denied that when we tried to reach here. And we had some matches when we tried to, when successful, we tried to reach our permitted server. So we had permitted, this was permitted to get there. This was denied to get here. And this was permitted to get here. All right, we are almost done. One more thing we need to do. Okay. And this is VTY access on the edge router. So on edge, I've configured telnet. Okay, this is showing SSH. So I'm going to change that to telnet. Okay, you should be using, as I mentioned here, this should only be used in a lab environment. Okay. So what we're going to be doing is creating an access control, actually a standard named access control list. Why just standard? Could do extended. That's fine. But we'll do a standard. Just the only thing we need to check is the source IP address. And what we're saying here is the only devices that we are going to permit access to Telnet into, and this same thing for SSH, this won't change, but remote access is from the 1042.0 network. And you see where we're applying this access list. We're applying it on our virtual terminal interfaces. This is where we configured Telnet or SSH. And instead of access group, IP access group, we're just saying access class. Okay. So let's go ahead and do that. And by the way, this is why it was important on Edge, because this is where we're going to be doing it. If you remember previously on Edge, and let me bring that up real quick. See if I can find it real quick. So previously on Edge, inbound, so let's find it inbound coming from, here we go. Remember we said we had to permit IP pack. So we want to make sure that we're permitting, because everything else we had to deny, implicit deny any, we want to make sure we were permitting packets from anywhere in our 10 network to at least the IP packets to get to 10, 200, 200, 205. If this is the destination IP address, they will be permitted. Now, once they get there, we'll see what happens. Okay, so let's take a look. Okay. So let me apply. I'm on Edge. I'm on Edge. No, I'm not on Edge. I'm okay. Okay, so here we go. So again, we're only going to be permitting devices on this network. That's maybe our IT department. And a lot of this is just, some of this is not perfect as far as I try and do best practices, but I'm also trying to show you different options. Okay, so let's do a paste here. Everything looks fine here. So what this tells us is that anything from this network should be able to telnet in. Let's try it. First of all, we should be able to ping. Now, this ping works. Anybody should be able to ping because we've done that permit on Edge earlier. Okay, now let's do telnet. And I chose telnet just to keep it simple. Lab environment only. There we go. If I can type in Cisco. There we go. All right. Now, if I try telnetting in from another device, let's see. From here now we are at PC 0. Connection refused. Okay. And again, show access list. Okay, there's our NAT, there's our outbound, there's our inbound, a lot of these inbound and between the DMZ. Here's our verifier remote access. Not a problem. Okay. And last but not least, we're all done. Don't forget, if you're doing my lab, save, okay? Make sure you save all this information. So, save your running configs, copy running to start, and also save your packet tracer file. And you should be doing that as you're going. I also want to mention I have some addendums here, talk about standard, it gives an example of standard ACLs and the sequence numbers and internal logic. But before that, here we go. I have an addendum that talks about routing protocol messages. I want to mention that we do not have to worry about outbound, right? So let me mention this real quick because I think I forgot to mention that with all of you. Okay, so let's on our outbound. So let's go to our edge here. This way. Outbound. Okay, we did not have to do a permit let me show you what we did up here. Okay. All right. Let me show you. Let me get there. Okay, so inbound, remember we did permit OSPF any permitted OSPF messages coming from core into edge. Okay. But what I want to mention is for the outbound, I gotta remember where that is that here we go. We did not put that. And that's because those OSPF messages are being originated by the router, so they're not being filtered by this ACL. So we just apply it inbound as they come in, but remember, any packets originated by the router are not filtered by the ACL. Okay, so anyway, I talk more about that here. I talk about standard ACLs and logic, some stuff on FTP. What do I have here? Oh, more about the FTP server and adding a file to your PC if you want to play around with that. All right. Well, I hope this helps. Kind of wanted to give you some real world best practices and hopefully understand a little bit more about access control lists. Have a great day. Thanks.